Good morning, ladies and gentlemen. In this video, I want to show you how to classify a satellite image by using the segmentation method with the Envi software. Before we start, let me define what is a satellite image. A satellite image is made up of a set of pixels. So this is the first thing. When you have your image like this, this is your satellite image. Then you have also one or each pixel has each pixel has, if I take this pixel, it has a radiometric value ranging from 0 to 256. This is each pixel on your image has a value range from 0 to 256. This is the one thing you must know. And also each pixel has each geographical coordinate. You know that a geographical coordinate is a whole of x and y coordinate. The third thing that I want to show you is that those values that you see here, when you see 0, that meaning that the sensor of the satellite has not measured any signal or light reflected from the ground or reflected from the object. And why this pixel can have a value 0 and another one or its neighbor would have a value of 1 or 255 or 100. Though the difference of value for your pixel depends on the intensities of light or signal reflected by the object on the ground. So depends on the light reflected, but you know that when the image are quiet, you know that there is a process so that object, each pixel can be attributed a value. So those value depends on the sensitivity of the sensor and also the intensity of reflected signal or light measured by the sensor for the satellite. And the fourth thing is that each pixel can represent, this pixel can represent 1 or 2 or 3 or 4 land use feature on the ground. It depends on the resolution of the pixel. Some satellites offer image with 30 meter of resolution. Some satellites offer image with 1 meter of resolution. Depends on the resolution of your image. The pixel can represent 1 or more land use feature on the ground. And why we want to classify the image, why we want to classify the image is to give a meaning of the pixel. But because when you say this is 1 0 1 0 1 0 0 1, any non-technician user, non-AGIS user can not understand the meaning of 0 or 1 or 256 on the image. You as a technician user, you must define what we call 1 1 on the ground, what we call 0 0 on the ground, what we call 0 1 on the ground, and what we call 0 1 on the ground, so that it can be understand the meaning of the image. And also whether you want to determine the area of your vegetation area within 2000 and 2010 to determine, to monitor the vegetation process to see whether if the vegetation is as a good health or not. And also whether you want to determine the urban area of any area from 2010 to 2020 to see if the urban area is on growth process or not. All those process, all the classification process is to support decision making on a particular problem on a particular area. So let me show you how we use to make image classification. Traditionally, when you have your image like this, and you want to classify, you have to determine some region of interest to say that all the red region of interest, all those are the vegetation area, and all the blue all the green color are called water body. So this method is good, very good, but it is only for a small area. That you know well the area, you can use this method to take your region of interest, and after you can use the region of interest to interpolate over all your image. But when you have a large area, a large image that you need to classify, you have to use, I recommend you to use the segmentation method, which consists only to tell the Envi software to determine, to extract the value, and to classify them as what you want. So the method consists of to tell the Envi extract me all the value with, donc extract all the value, let me write here all the value of 0, and range them as vegetation. Extract all the value 1, all the pixel with radiometric value, let me precise, with radiometric value 1 as water body. So the software will extract exactly those pixels and range them as land use classes, range them as region of interest, and after you are going now to use those region of interest to interpolate all over your image. So I hope this part you understand, and if everything is okay, let us go on the practical. So I am going to open my Envi software. After open the software, go to file, open image file, and navigate to your working directory. I have my data here in the folder Landsat with folder. So this is my image, Imagery 4, 3, and 2. So this is my image, so I am going to load that image as RGB color. Then the first thing you have to do is to list all the classes, all the non-view classes present in the area. So I'm going to open my notepad. Let me open notepad plus plus so that you can view it. Let me close all those things. So we are going to list all the classes. When I am running over the image, I can see rapidly, quickly, 3 classes is water body, vegetation area, and bare soil. Water body is the blue color, vegetation area red color because the image is a false color composition, and the white color is represent the bare soil. So this is the first thing we just do. So the method of using the segmentation is to determine the mean and maximum radiometric value of each land use features. So determine the minimum and the maximum radiometric value of each land use feature on the image. Donc point 1 was to list all the land use features, and the point 2 is to determine the minimum and the maximum radiometric value of each land use feature. So let me do that exercise. Donc I will just write minimum and max and just copy and call. Okay, so for the water body, how we are going to determine those values is to make right click on the image windows, cursor location value. Then when you run over the image, you can see the value on the SCM line, or just use the data line to get your data. So what is easy to do is determine in which band we have the value, where we can extract easily the value. So you can see that in the red band we have 00 for all the water body. So this is a quick method. So we can just put here 0 and 0 as min and max, but this does not apply for the all study area. So it depends on your study area. So but you have, for any study area, you have just to determine the minimum and the maximum of the area. So let us go for the vegetation area. Here we can see that we have a 00 for the green and the blue band. So here we have, let me put here that is on the band red band, and here we have also 0 and 0 for the blue band. And let us do now for the gear soil. We have the gear soil here. You can also use the zoom in and zoom out tools to zoom your image. Down here we have 255 for all the band. Down 255 for all the band, so I can just use 255 like as minimum and 255 as a maximum on the band, on the red band. Okay, so we just finished with the second process, with the second exercise we must do. So let's go to the third method. The third exercise is to make region of interest, from those values. Okay, so on the image window, go to overlay, region of interest. Let me bring this. So we want to extract the water body, so just go to option, band threshold to ROE, and extract. You remember that we take the value on the red band, so just click red, okay, and put 0 and 0 as water body. Now we can put green or blue color, no problem, and click OK. I want to add my data. So you can see that the software extracts exactly my water body, exactly the water body from my image. So the method extract exactly your land view feature for you depends on its radiometric value. So let me delete the default region 1. So I want to do the same thing for the vegetation area. Don't remember that we take the value on the blue band, so I will just select the B band, blue band, and put 0 0 as min and max, and here I will just put vegetation area. Don't let us take the green color for that. And you can see also that all the vegetation area, not all, but it is some region of interest, is not to digitize all the image, but just to take some region of interest and use them for interpolation. So that is okay. Let us go for the gear soil land use classes. So I'm going to do the same thing. We take those value on the red band, so I will just select the red band and put 255, and here I will just put gear soil, and I can take the color cyan or yellow, any color you want for that. So I will put OK. So you have also your gear soil that has been extracted for this area. Don't take it because this is a out area. This is not concerning by my study area. It's only the study area like this. So after the classification, you can just export the result to the GIS software like QGIS or ArcMap, so that you can extract exactly the data for your study area. So when this is done, let us go to File from the ROI Tools windows, File, Save ROIs, and select all items and choose to go to your working directory, classification, segmentation, Landsat width, and put ROI as your ROI names. Is okay. So after this, we are finished with the exercise 3. We are going now to exercise 4, that is to make interpolation. Make interpolation with the minimum distance method. Minimum distance method. Okay. So I can close just this window and go to classification, supervise classification using the minimum distance because we have extract our value with the method, with exactly method. So you can take minimum distance to show that the software can determine in between a few distance which pixel and which pixel to combine them to have the proximity of its neighbor pixels. So let me select my composition, my color composition 4, 3, 2 image. Then here the second parameter is to select the land use classes extract from the region of interest process, the exercise 3. So here let me do, you can just press here to bring the output raw images as you know, and choose to make min class image classification image. Okay, so I can load now my image here. I can load the image, and if you want, you can see that it extracted all the land feature with the exactly method, because we have used the radiometric value of the pixel to extract the features. So to show you how the method is accurate, is to link the windows. Let me link the two windows so that you can see. You see here that when I link all the windows, you can see that it is exactly what I want that has been extracted down. So here you have the vegetation area. Even when you see here where we have a linear object represent the water body, you can see that the object has been extracted with the accurate method using the segmentation method. So from that you can do everything. You can vectorize your classification to vector, to vectorize the image and export them to GIS software to extract only the data for your area, and also to calculate the area of your land use features, and also to make a map, to prepare a good map, and also to put that map on your report, on your presentation, and do so on. So ladies and gentlemen, we are on the end of this video. That was to show you how to make a satellite image classification by using the segmentation method. That is a method that can give you a good result, a accurate result for your classification images. I hope this video helped you. If you have any question, no problem, you can just write under the video, and I will try to respond. And also, before you leave this video, don't forget to like, to share, and also to subscribe to our channel so that you can be aware of a new video for you. Thank you very much, and see you in the next video. Bye.